Hello, good morning, and welcome back to the channel. It's always beautiful to have you here. Remember to like and subscribe to our content. We are also committed to continuing to run this series. Today, we are going to talk about MIC and MBC. MIC is minimum inhibitory concentration. MBC is minimum bactericidal concentration. Now, these are parameters and terms that are important in antibiotic susceptibility testing. We just finished describing what it means to do a disc diffusion test to be able to run an antibiotic susceptibility test. Now, I want to look at MIC and MBC. Now, these are parameters in which we are interested in looking at the ability of an antibiotic either to stop the growth of microorganisms or kill them totally. Then not only are we looking at the ability, we also want to ask ourselves at what concentration is the antibiotic able to either stop the growth of the microorganism or even kill it totally. So these are what we look at when we measure MBC and MIC, and they're very important parameters in science. And when you look through it, there's a procedure for running the MBC and the MIC. In fact, we say that we pick when we finish doing MIC, that's minimum inhibitory concentration, then we'll try and do MBC from MIC. And so when you think about it, you prepare a series of antibiotics brought at different concentrations, because the idea is you want to look at the effectiveness of the antibiotic and at what concentration, because this is important because it helps to inform dosage, how much of a dose of an antibiotic should be administered in order to be able to destroy a pathogen. So you prepare different concentration of antibiotics at different concentrations. That's what you prepare at first, and then when you do that, you have your wells, which you now inoculate with a standard of pathogens, bacteria. So the idea is that you want to make sure that you're putting the same amount of bacterial cells into each of these wells. This is important in order to standardize the test. So you have the wells, you inoculate your wells with a standard, an agreed upon set standard of pathogens, microorganisms. And when you have done that, you now add to all these your wells, you add your antibiotics of interest, but there are different concentrations now and they are well labeled. So you know the different concentrations, and then you have labeled them. After you have done that, you incubate for 24 to 48 for 12 to 24 hours. When you finish incubating, then you observe for turbidity. We already know that microbial growth, the indication for microbial growth in a broth culture is turbidity. The more turbid, the more unclear that the broth looks, we know that there's microbial growth happening in that solution. That's why it looks unclear. So you now begin to view all the different test tubes, all the different wells that you have inoculated, the test tubes. You start to look at them differently. And what are you looking for? Where you see turbidity, you know that the microorganisms are still growing there. So you look for the ones that are clear from the concentration. And remember that your concentration is graduated. So what I mean by graduated is that maybe you're using 5, 10, 15, 20, 25, 30 milligrams of the antibiotics of interest. So you begin to look where you have turbidity in your test tubes. Then you can say that, oh, that means that the microorganisms are still growing alive and well. But wherever you see a clear solution, from that point onward, you know that the growth of the microorganisms have been stopped in that first clear solution. Now, the first clear solution with the highest concentration is what you refer to as your MIC, which is your minimum inhibitory concentration. So that is the concentration. So it's a bacteriostatic concentration. It's a concentration at which you realize that the antibiotic is able to stop microbial growth, but you're not yet sure whether the antibiotic is able to kill the microorganisms, because there are two things. You're looking at bacteriostatic, bactericidal. Bacteriostatic meaning that you're able to stop microbial growth. Bactericidal meaning that you're able to totally clear or kill microorganisms and they can't grow. So the first concentration at which you see clarity, you see a clear solution, that's the concentration that you take as your minimum inhibitory concentration. Now, after you've gotten this concentration, the next question to ask is, how do we know the minimum bactericidal concentration, the MBC? Is a simple test to do. You now look at all your clear solutions and then you inoculate out of those clear solutions into culture media that have no antibiotics. So the idea is that you're trying to look at if any of the cells are still viable, any of the cells from those solutions, are they still viable, are they still able to grow. So when you inoculate from each of those clear solutions onto petri dishes that have media that have no antibiotic, then you watch any of the I say you watch, you incubate for a period of time and then you come and observe. When you observe, what are you looking for? Any of the plates that still develops microbial growth on such a plate, you know that what has happened is that that concentration, that clear concentration, was an MIC, but the organisms were not dead, they are just impeded from growing by the bacteria. But you get to a particular plate where you observe no microbial growth. For that concentration, you've labeled your concentration on the petri on the test tubes that you initially carried out your MIC on. That particular concentration that you now plated for your MBC, in which you see no microbial growth at all, at that concentration, that's the concentration you call your MBC, your minimum bactericidal concentration, because this is the concentration at which obviously your organisms, most of them have been killed and they are unable to grow once again. So these are simple parameters. Remember, like, subscribe, share, and let's keep discussing. Let's keep this community alive. Thank you and have a beautiful day.